Hello everyone, and welcome back to another video by me, Simon Sorensen, where we will be comparing infrastructure as code tools. So I thought I'd just create this very nice keynote, and whenever I touch PowerPoint, or in this case Apple Keynote, I always go overboard with the effects. So bear with me, I've added an effect to pretty much everything. But yeah, we're going to be comparing three infrastructure as code tools, namely AWS SDK, Terraform, and Pulumi. So, just a quick overview. AWS CDK. You can write in TypeScript, JavaScript, Python, C#, and Go. It's AWS first, but there is some support for third-party modules. And it uses remote state managed by AWS. That's sort of like the whole big thing, is that instead of saying there is a cloud offering, it is just the state is just managed by AWS. And also the infrastructure changes is run on AWS, so nothing is done by your machine. And as I said, cloud only. It is not possible to not do cloud. Then secondly, we have Terraform, which uses not a programming language, but more like a markup language called HCL, which is by HashiCorp. I think it is HashiCorp language. There's over 2,600 providers for different cloud services, so Terraform is definitely the largest one. It uses state. And the reason I mentioned that is it's also possible, instead of using state, so where each tool remembers what it's done and then it compares it to how it looks and so on, some tools will look at the actual infrastructures and then determine what to change. And cloud optional, so there is a cloud offering, but you can also store the state locally or in an S3 bucket or Azure blob storage or whatever you want. Oops. Then there's Pulumi, the last one. Oh, I like this effect a lot. That one is also in normal programming languages, so TypeScript, Python, Go, C#, Java, and YAML, which is a markup language. There's over 100 providers, so not nearly the same amount as Terraform. Also uses state. And cloud is also optional. So I'll be building a small demo. Well, I say small, it's actually quite big. A demo application in each of these three tools, which looks like this. Huge apology for the low resolution, but I've built this application before in my introduction to AWS basics. It's a simple tool where you have a Lambda function that receives a URL, then pushes it onto an SQS queue, which is then received by another Lambda, which then downloads the image and puts it in an S3 bucket. So when we build this, we're going to be dealing with S3 buckets, SQS queues, Lambda functions, Lambda IAM roles, some policy, Lambda function URL, and that's that. But it is quite a bit. So, time for demo. If you want to follow along with my demo, you can follow along, or you can just watch it to see, which tool you prefer, which one you might want to go more into depth with. But if you do want to follow along, you need an AWS account. You will need the AWS CLI installed and authenticated, and you need Node and NPM, or PNPM or Yarn. Up to you. But in this case, I'm just going to use NPM just for simplicity. So first I'm going to run npx CDK init app language TypeScript. There we go. So npx is a special npm command that will let you run a CLI from a package without installing it, or it's a little more convenient. And apologies if I do some spelling errors. My microphone is on a pillow, so you can't hear me type on my keyboard, but it is kind of blocking my access to the keyboard. Anyways, let's open up this folder here. Here we are. And this is a base CDK project. So we have our stack, which is where we do everything. And then we have CDK here, where you can give some information. I'm not going to change anything here for the time being. So first of all, I'm just going to create a new folder called functions, and then put in our 2 Lambda functions that I've already created in the previous video. So the first one here you call, and then you give it a URL that will be pushed onto a queue. I'm going to paste that in. And then the second one, called download image, which will go to that URL and then download the image that's there. Just copy that in. There we go. That's good for now. Then I'm just going to make a quick change because the queue URL is hard-coded. That's obviously not going to work because there's no way to know the correct URL for the queue. So I'm going to change that out to pull it from the environment. Like so. And I'm actually just going to quickly do the same in download image, except for the bucket. Again, can't guarantee the bucket is going to be called Papa's images, so let's change it out to image bucket. Cool. Then let's go into our stack. This is where the magic happens. So first, let's uncomment SQS because we do actually want that. Then I'm also going to import Lambda. Like so. And as you can see, there's all of the AWS services here, as you would expect. And then also IAM. So one of the benefits of CDK, and apologies if I do sometimes say SDK, what I do mean is CDK. One of the advantages is that there is day one support for all AWS services and any changes to existing ones, which there is not always on Terraform and Pulumi. Okay, well, I'm also going to uncomment this because we do want a queue. I am going to call it image queue, however. Yep. I'll also delete this. Let's call it image queue. And the visibility timeout is fine. So, in our code, we're saying we want a new queue. This here is I'm going to actually call it image download queue. It's a name we give it. It doesn't have to be unique. That is something CDK will take care of, ensuring that name is unique by adding some randomness at the end of it. Then let's create our function called receive image URL func, and that's going to be equal to a new Lambda function. This, so we give it our stack, and we're going to call it receive image URL, and then let's give it some parameters. So first, the runtime is going to be node 16. So that's lambda.runtime.node 16. The handler It's going to be first the name of your function file, which is receive image URL, and then the name of the function within that file that is the handler. In our case, it's handler. Then the code. So in CDK, you can do lambda.code.from asset. Not resources, functions. And then environment. So we have to give it that Q name, was it? Q URL. And this is very simple. So then you just do is equal to image dot Q URL. There you go. Then this function needs a URL so we can access it. So let's give it a public URL. So I'm going to do receive image URL func URL. And I'm going to add a function URL with no authentication necessary. Function URL auth type dot none. And there we go. Then we need to give our function permission to send messages on our queue. So I'm going to add that to its role policy. Here we go. Add a new policy statement. And the actions it needs to be able to do is SQS send message, and it needs to be able to do it on these resources, which is our image. Oh my god. Image q.qarn. And then just for convenience, I want to output the URL for the function. And that we can do like this. See, receive image URL, and the value is dot URL. There you go. So that's part of it done. So first, I just want to show you a little bit about this. So we do npm run CDK synth for synthesize. It's going to convert the, oh, no, it's not. I made an error. Let's see. There's already a construct with receive image. Have I overwritten? Yes, I have. There. That's my bad. Let's do it again. So it's going to synthesize the code we've written into a CloudFormation template. As you can see here, it's not the most fun to write, so I wouldn't do it. And that's where CDK comes in, really. So CloudFormation is the tool within AWS that's going to receive this, and then it's going to create the resources for us, and it's going to make updates as necessary. So actually, let's try and deploy this. We do npm run CDK deploy. It's going to synthesize this, and then it's going to send it up, and then you can see here, the changes it's going to make. That's fine. Yep, go for it. So currently, our machine or our computer is not actually doing anything. It's just sending the template to CloudFormation, and then it's connecting to CloudFormation to tell us what's going on. And I can actually pull it up. So if we go to CloudFormation, there it is, create in progress. I'm just going to show the same things it's showing here. Now, creating resources in AWS can sometimes take quite a while. So something that is common across all infrastructure as code tools is that deploying changes takes a long time, usually, unless it's a small change like you want to change the actual function code. That's usually a pretty quick change, or the handler in a Lambda function is a quick change. Modify an SQSQ, relatively quick. But as you can see, creating a queue itself can take a while. IAM policies are also usually pretty quick. But just in the interest of time, I will be right back when this is all done. Alright, I'm back and it has finished. As you can see, it took almost 145 seconds, which is a long time. But subsequent changes won't be as slow. So it's outputted the URL for the function. So let's test it out really quickly. I'm just gonna give it a little URL for a sample image. Give me a sec here. Pop that in. And the correct response is no response. So yes, that worked. Let's quickly pull up the queue just to check. Here it is, image download queue. Send and receive, and oh, that's concerning. Let's try it again. Oh, okay. Ah, right. It's this one here, which makes sense. I should have really foreseen it. I was explaining to you that, CDK adds a bunch of extra stuff to ensure that it's totally unique. So this one is one I created a while ago when I was demoing something. This is the one, and it will have the messages available here. There they are with the correct URL. Cool. Well, let's type out the rest of our application. So let's get on with it. So first, we need to update our imports or add a couple new ones. So we also want S3. Oh, yes, S3, nice. And then also an SQS event source from Lambda event sources. So that's like this. There we go. So let's create our S3 bucket. I'm gonna call it image bucket. It's a new S3 bucket. And let's call it images bucket. And let's create our second Lambda function. Const download image func. It's going to be another Lambda function. Call it download image func. And again, same runtime. Node 16. Handler is going to be download image.handler. And code will be the same. And then environment, we have to give it the bucket name. And what did I call it? Image bucket will be equal to our image bucket dot bucket name. Whew. And then we have to give it a couple of permissions. So first we have to give it access to write to the bucket. Let's create a policy statement here. So the action in question will be S3 put object. Yep. And the resource in question will be that image bucket. Bucket on. Then we have to give it permission to read from the message queue, which we do like this, another policy statement. And there's 3 actions, so it's SQS receive image, SQS delete message, and obviously not receive image, it's receive message. My apologies. And then it's SQS get queue attributes, and the resource in question will be the image queue.qarn and its actions there. Cool. And then we have to add the trigger. So the function triggers every time there's a message on the queue. Just like this. And like that. Nice. Let's deploy this. All right, it's finished updating everything. Took almost the same amount of time, so a little unfun. But let's see if it works. Let's trigger our function here. Good. And let's go into S3. And it should be this one. No. Is it? This one here. CDK stack. Okay, yep, so it didn't work and I've figured out why. So when you give a function or anything access to S3, you can't just give access to the bucket by its own. You also have to give it a wildcard if you want to give it access to everything. Normally you would probably give it access to a certain prefix within your bucket. But in this case, you know, it's just a demo application. So with this change, let's deploy that. And then it works. I promise you. I promise you my kidney, this works. Small change, should be very quick. Crossing my fingers here. Okay, changes have deployed. It wasn't particularly quick, but let's check it out. So if we're lucky, the S3 bucket will have some images. If the messages haven't timed out. Okay, they might have. Let's run it again and check it out. Ta-da! There we go, it works. So that is that little demo application in not that much code. There's a lot of helping out from CDK. So for example, when you create an image function and you want to upload some code, what you really have to do is typically you would create an S3 bucket, package up your code, upload it to that bucket, and then tell Lambda, you know, the code is in here, pull it from there, and so on. Also, there's log groups that you have to set up and give permissions, which is also done automatically by CDK. So it's definitely a really, really good choice if you are using AWS, but also be aware that it's pretty much AWS only. It isn't quite, because there also is third-party module support, but something like Terraform has much better third-party support. Well, I guess it's not really third-party, it's just support for all sorts of different things. There are also tools for Azure and Google from Microsoft and Google, like CDK, which is native to Azure and Google Cloud. But since I'm not familiar with Azure or Google Cloud that much, I didn't want to demo it here because, you know, I have to be a credible voice. So I'm only demoing things I know. All right, next up, Terraform. Welcome to Terraform. If you want to follow along here, you will need the Terraform CLI installed and, as before, AWS CLI installed and authenticated. Alright, so I'm just going to do all of this in one file that I'm going to call terraform.tf. Then we are going to tell Terraform that our required providers today is going to be AWS, and the source is going to be HashiCorp/AWS version 4, which you do like this. It's a tilde and pointing, or well, a less than, and then 4. And then I'm just gonna tell the AWS provider that the region we want today is gonna be EU West 2, which is London, where I live. Okay, then I'm gonna run Terraform init, which is just gonna download the provider, create some state files, and so on. There we go. Been initialized, and we'll see some new function or some new folders. Then I've copied over the functions from the CDK project. And so CDK gives you a lot of help. As I said, Terraform does none of that, or the Terraform AWS provider does absolutely none of that. So we have to do everything manually. So be ready for a little bit of a bigger file, but it might be worth it in the end. So first, we are going to create a zip archive of our Lambda functions. So within Terraform, you have data blocks, which will fetch some data that you can use. And you have resource blocks, which will create resources. And then the archive file is a sort of a special data block, which will actually create an archive. So we're just saying, zip functions folder to zip. Then I'm going to create a resource. So whenever you create a data or a resource block, the first string is going to be the actual resource type. So in this case, it's going to be an S3 bucket. And then the second part here is the name, which has to be unique within your Terraform project. So I'm going to call it Lambda bucket. And if you don't give it a name within the block, then Terraform will give it a globally unique name. Then we need an AWS S3 object, which will allow us to upload those functions. So we could do Lambda functions. I'm going to rename this to Lambda functions archive. All right. And then we tell it which bucket. So whenever you want to reference data that's available from your Terraform context, first you would do, well, here it's offering to auto-complete it. You tell it the provider, which is going to be AWS 3 bucket, and then the ID or the name you've given it. And then ID is what we want. Very nice. We tell it what key to use. And source, which is going to be archive file. Oh, no, sorry, data. Data.archivefile dot output path. Bit of a mouthful. And then an e tag, so it knows whether to upload a new one. Just gonna copy that over. There we go. Then I'm going to create the IAM policy for our first function. going to be AWS IAM role. I'm going to call it receive URL func role. And in this case, I'm just going to copy over so you don't have to watch me type it out. So first you would do assume role policy. And this is something that's pretty standard. CDK does it for you. Yep. And then I'm going to give it an inline policy, which is going to allow it to send stuff on our queue. Now, here's something. Notice how we haven't created our queue yet. Now we will do that later. We'll do it at the bottom. So don't worry about it for now. Let's create our function. So it should be an AWS Lambda function. I'm going to call it receive URL func. In this case, we do have to give it a function name, so I'm going to call it demo receive URL func. The runtime is going to be Node.js 16. And then here we have to tell it the source of the source code. So I'm going to tell it look within this particular bucket and then look for this particular key. And then the source code hash, which is just going to be the SHA-256 of our functions file. And the handler, like before, will be the name of the file dot the name of the handler. Yeesh. Yep. Then the role is going to be equal to the one we've just created. Arn. And then we also have to tell it our queue. New queue URL will be equals to AWS SQS queue. Oh my god, I'm messing it up badly here. Okay, SQS queue. We're going to call it image queue, and then the URL. Here we go. That's the first function done. Almost. We just need to quickly give it a URL so we can access it. Receive URL func URL. I'm not a huge fan of the is it an acronym or an abbreviation? I believe it's an acronym, URL, over and over. Anyways, there we go. And then quickly authorization type none. Cool. Now that's done. Now at this point, this wouldn't work because we haven't created our queue yet. So I'm going to hold off on running this. And for convenience, let's output the function URL. Receive URL func. Value is going to be equal to AWS dot function URL. A convenient thing about these outputs is that you can actually get the values from the CLI in a programmatic way, which is convenient for CI and scripting and so on. Anyways, let's create our last function. So again, I'm just going to copy over the policy just to save us a bit of time. It's a bit of a big one, but again, it's just the assume role policy that you need when with for Lambda functions, and then we are going to give it the ability to put objects in our S3 bucket and read from our SQS queue. And I will copy this part here, the Lambda function. Copy it in. I'm going to give it a new name, of course, which is going to be download image func. And again here, demo download image func, and also here it would be download image, and the role will be this one here. And then we need to give it that image bucket environment variable, and the value is s3 bucket dot image bucket images bucket dot id. Whew. And then let's make it so this last Lambda function is triggered by our queue. So AWS Lambda event source mapping. I'm just going to call it image queue Lambda trigger. The event source arn is going to be our queue. SQSQ dot image queue dot arn, and the function is going to trigger is going to be AWS Lambda function download image func dot arn. Cool. And I'm just going to indent this. And then lastly, let's create our actual bucket for the images. And the queue. And there we go. So the reason I put these two at the bottom is because I want to show you that even though it's at the bottom, Terraform is intelligent enough to understand that it has to create those first to be able to give permission to the Lambda functions. Hold on. Oh, I forgot to save. Oh my god, I got a little bit nervous there. Alright, we have to do Terraform init again. There we go. And then Terraform apply. Oh, indeed, I see. Alright. Yeah, so this hash, it's not possible because it's referring to a file that doesn't exist yet. So it is optional, so I'm just going to comment it out. Bet there's probably a much better way to handle that, but at this case, it's not too relevant. So it's going to add 10 resources, which is correct. And I'm just going to say go ahead. And as you can see, it's creating the queue and the bucket, the S3 bucket first, before it goes on to create anything else. And this all, whatever can be in parallel, happens in parallel. So yeah, I'll be right back when this is over. Okay, we're back. Everything has been deployed successfully, and we have received our function URL. So I'm just going to copy it in. And I'm going to replace this with our new one. And let's run it. Yep, looks good. Let's see if there's anything in our bucket. So the bucket is going to be called Terraform and then a very long number, which is a timestamp. Now the date doesn't look right, so let's refresh. Here's a new one. This is the one. So the first one is going to be the one with our functions in it. And the second one is with our images in it. And there it is. Nice and safe in here. Cool. So this is Terraform. A little bit longer code, a little bit more verbose. The roles aren't handled correctly, or not correctly, but automatically. And something that's missing here is locking. So the Lambda functions are unable to output any logs to CloudWatch because I haven't set up the proper permissions. I've decided to skip it for this demo because we don't need to do any debugging. I've already done all that. I just know it's going to work. But if you use Terraform, do make sure to give permission to CloudWatch log groups. So let's bring it down. Terraform destroy. We say yes to that. And everything's going to be fine except the SV bucket, which you can't delete when there's anything in it. All right, everything's been destroyed except the SV bucket. Now let's go on to Pulumi. Alright, welcome to the Pulumi demo, where I'll show you how to implement our demo application in Pulumi. First of all, I'm going to log in with --local, which tells it to use local state. Obviously, don't ever do this in production, but I'm just going to do it now because I don't want to be demoing the cloud offering or anything like that. Then I'm going to do Pulumi. New AWS Go. Yeah, it's not empty because I have copied over the function, so I'm just going to do force because it's fine. Project name, I'm going to be calling it IAC demo. And yep, looking good. The region, I'm going to do EU West 2. And then it's going to install the dependencies. Now I'm getting a little bit tired. It's later in the evening, so I've brewed myself a cup of coffee. Well, it's an espresso. I don't know if that counts, which I will be drinking shortly. Also, I'm not going to type out everything. I will be copying over some things and then explaining how it works. Because here's our Terraform stuff. Let me just open up our Pulumi folder. Because what you'll find in Go is that Go can be quite verbose. So the error handling you have to do manually. I like Go, but yes, it is quite verbose. So of the 3 tools, this will be the biggest in terms of line count. This is not necessarily the fault of Pulumi, it's just because I'm showing how to use it in Go. Alright, with our Go tools installed, I'm going to maintain the bucket it's given us here. I'm going to rename it to images bucket and export it so we can see it, see the name. Now, not strictly necessary, but we'll do it anyway. Then I'm going to create a queue. And yeah, this is pretty much like CDK. One benefit of Go is the automatic imports. So you still need to import stuff, but if you have all the tools installed, it will do it automatically for you. And there. Cool. Now, you see, the thing about Go is it's standard for functions to return something, the thing it wants to return, and also an error, because you can return multiple things from functions. And then you have to manually check if that error is not empty, then send it up. Where in some other languages like JavaScript, if you throw an error, it's going to get thrown all the way up the stack until something catches it, or it doesn't get caught and there's a crash. or an exception. Well, I guess it would be caught by the browser or a node or something. But in Go, you have to manually check for errors like so. You can't just throw them and then they'll be caught, because if you don't catch them yourself like this, it will panic and then the whole program crashes. So let's create first our role for our Lambda function. Again, this is just the assume role. I'm just copying it in, and then I'm also going to copy in the policy, which will give access to the SQS. So a little bit of an interesting thing about Pulumi here is that at this stage, this queue here hasn't been created yet, so you can't just do image queue.arn like you can in CDK. Instead, you have to do image queue.arn.apply t, which will tell Pulumi when you've created the queue and we have the arn. Then I want to create a policy JSON and put it in here. And then with that, we are going to be creating an IAM policy, and then we're going to attach it. Oh, sheesh. So all of this is just the IAM stuff. So quite verbose. And then let's create the appropriate function for that we created our IAM role for. So I'm going to call it receive URL func. And remember, we have to catch the error. And then we do lambda dot new function. We give it the context. So this is similar to this in CDK, where you give it the stack. And then I'm going to give it a name. Again, this name here is just for Pulumi, so it has to be unique within your, your Pulumi application. Do function args. So then the code. Pulumi is able, unlike Terraform, Pulumi is able to zip up your function. Oh, no, it's not. I take it back. I've just double checked my notes. We have to do it manually. But what it is able to do automatically for you is create an appropriate S3 bucket and upload it there. So let's actually, that's not it. Let's zip up this. Let me show you. Here is our Pulumi folder. So I'm going to zip it, compress. Boop. Thank you, Mac OS. There we go. So I've just zipped it. Then again, just like before, handler. Every time you want a string, you have to convert it into a special Pulumi string. And then the runtime, Pulumi.string node JS16. And then the environment. So it knows, just like so. Let me see. My bad. There we go. Variables. Pulumi string map, and we gotta give it the queue URL, which will then be image queue dot URL. So when we want to use a value of a resource that Pulumi creates whenever you don't need to use it within a string, like this policy here, where this policy compiles down to a JSON string that we need to send off to IAM. Then you have to use the apply T to compile it into a string whenever we have the value. When you don't need that, where you just have to say, this thing is equal to this thing, or this thing is an attribute of a resource, you can just use it directly, and that will work fine. Sorry if I've confused you a little bit there. Let's handle the error. And let's attach a URL. I'm going to call it receive URL func URL. And then lambda new function URL. Give it the context. Give it a name. And then some inputs. And then just the function name, which can be receive image URL func dot name. And then authorization type Pulumi string none. And then catch error. And then also I wanted to export this URL so we can see it when we've applied our infrastructure. And do receive URL func will be equal to receive URL func URL dot function URL. Yeah, URL doesn't sound like a valid thing to say anymore. All right, then I'm just going to copy in the policy for our download function role, which is, it's a big one, I can assure you. Very big. Here it is. So again, the assume role that you need for all Lambda functions. Then the policy to receive from the SQS queue. Again, we have to, since we want to compile it down to a JSON string. The same with the bucket. Yep. And then, yeah, that becomes a policy. And then we attach these two policies to our Lambda function role. And then just in the interest of time, I'm going to copy in our function. I've already showed you how to write it out. Again, same code points to the functions.zip. We give it the appropriate role, the handler, and so on. Just want to make sure it is images bucket or is it image bucket. Let's just correct that. And then the very last thing, now again, I've done this quick here. The very last thing is we want to attach an event source. We do new event source mapping. Give it the context. Give it a name. Image queue download trigger. Give it an input. Like so. And then the event source arn will be image queue dot, oh, not that, dot arn. And then the function name, which is going to be the download image func and also its arn. And then we have to catch that error. And that's actually it. So I've saved a bit of time again by copying in some stuff. So let's apply that. So that's going to be Pulumi up. And then it's going to go ahead and, well, first it's going to download AWS. Now, while it's doing that, I'll just explain a bit about Pulumi and AWS. So the plugin we're using here is the AWS native. So that's where Pulumi goes to the AWS API and creates all these resources, and it manages the state itself. There's a new one that connects to CloudFormation that will essentially make it like CDK. So if you're interacting with AWS with Pulumi, it will be almost identical to CDK, especially if you don't use Go and you use TypeScript instead. Then it will look almost like what we did. Of course, you can use CDK with Go. Yes, you can. So, yeah, that would be a really good, or that would make Pulumi a really good choice because it can look very similar to CDK. And it also has excellent support for some other big services. Obviously, you got Azure, which has good support. Google Cloud, which has good support. Also, DNS providers. Now, they only have, at the time, 118 plugins available. But there's still, lots of big ones that you might want. Anyways, let's it's done deploying. So let's see if it works. Well, I'm gonna replace this URL here with the new one we've been given, and the correct proper output would be nothing. Oh. Well, let's just quickly debug what's happened here. So let's hop into Lambda, which is here, and check out our function, which is this one, which has just errored. Let's see, configuration, permissions. Should have permission to, oh, I know what it is. QURL, and what it's really expecting is, oh, I know what it is. Yeah, it's the handler. I've written something wrong. Receive image URL dot handler. Something wrong with this zip? Maybe? Yes, there is. Okay, well, that was a little live demo of how you always run into errors. So the problem here is this zip file in question contains a folder called functions, and then within that you have the functions. That's not what we want. So I'm just gonna delete this. Away you go, and then I'm gonna compress these into a zip archive. And I'm gonna pull it back and then rename to functions. And then I'm gonna do Pulumi up again. Yeah, and as you can see, it's gonna suggest the difference is the code. So I'm gonna say, yep, looks good with me. Okay, now that change has been applied, and let's reload here. Yeah, now that looks good, and let's try again. Perfect, and let's hop into S3 and find the bucket it's created, which is going to be this one here, this one. And there's the image 2324, which is now. So that was a brief overview of Pulumi, and hopefully that will give you some insight into which tool you think you might prefer most, or which one you think might be the most correct for you. They share a lot of concepts, so if you learn one, you sort of, not quite, but you sort of learn another. So yeah. And again, infrastructure as tool or infrastructure as code tools, they are an absolute must in any production environment. The AWS console is nice, but it is really not intended to set up application infrastructure. It's intended to experiment, test out stuff, look at things, which it's very good for, but not for setting up big applications. Anyways, thank you for watching, and I hope I have shared some useful knowledge, and I'll see you in the next video. Bye bye, everyone.